Hey everybody, my name's Robert Douglas, and I am the host of Deploy Friday. It's Friday, it's the best day of the week to deploy all of that code that you've been working on all week, commit it, push it, set it free. Nothing can go wrong. Nothing will go wrong, I promise you. It's my personal promise to you. This is the webcast hosted, sponsored by Platform.sh. A platform is a service that will help you on your quest to make Friday deployments painless and safe. And today I have guests joining me from Fastly. Fastly is what's known as a CDN, a content delivery network. But as we're going to discover on this show, Fastly is much more than just about being an HTTP cache in the cloud. And I have guests Vladimir, Vuksan, and Teddi Poehls with me to talk. In particular, we're going to talk about computing at the edge and the security stack that Fastly is able to offer. I would like to mention upfront that Fastly is a longtime partner of Platform.sh in our product stack, and that our enterprise and elite tier customers get managed Fastly deployments for their web applications out of the box. And that is a great value and a great complement to the core product that Platform.sh offers. So I'm also happy to be talking today to our partners from many years. It's been most of a decade already. So let's start with you, Teddi. Who are you? Where are you? What's your role at Fastly? What brings you to the conversation?
Yeah, thanks, Robert. So as Robert said, I'm Teddi Poehls. I work at Fastly as the Director of Channel Engineering. I hail from the great state of Texas. I live in Dallas, Texas. And I actually came over to Fastly through the Signal Sciences acquisition that happened last year in 2020. So I really focus on our security portfolio, and I've been selling security software as a sales engineer for the last 7 years. But I actually started my career as a practitioner, working for Fortune 500 and larger companies in operations, networking, and security. So I'm here today so that I can talk more about our security offering and kind of what we see when it comes to attacks at layer 7 and kind of where we're going for our customers.
Attacks at layer 7. It sounds so ominous. Thank you. Welcome. Vladimir, how about you? Who are you? Where are you? What brings you to the conversation?
So Vladimir Vuksan. My role is Senior Principal Channel Engineer, which is very closely related to our sales engineering org. So like Teddi, I was more of a practitioner before getting into sales. I was actually one of the initial technical operations, what now would be deemed SRE for Fastly. So I've been involved in managing, building a lot of our early infrastructure, but then I discovered that I like talking to people. So
I'm glad.
So I ended up on the kind of more on the sales side. So now I do sales mostly, and I am in Raleigh, North Carolina, the Triangle area. So yeah.
Fantastic. Thank you, and welcome to you as well. Let's kick off by talking a little bit more about the history of Fastly, what Fastly is, and a little bit about what it's become. So on the street, Fastly at inception was known as varnish in the cloud. And I think that was a very useful way of orienting that for the demographic that I came from, in particular with web applications, Drupal, WordPress, that type of CMS type site with lots of content, much of which could be statically cached, benefited greatly from anything varnish. Okay, and varnish distributed in the cloud around the world was even one step better, and people already understood VCLs and making varnish CLs, varnish something layer, varnish cache language. I don't know. What does it stand for?
Varnish configuration language.
Yeah.
Configuration language. It's so simple. So people who could write VCLs really, thought, that's great, varnish in the cloud. So is that how Fastly began, and what have you become since then?
So yes and no. It was, I think when it started, it was I think we went as CDN and Varnish as a service, because everything 10 years ago was as a service, database as a service, mobile database as a service, and so on. But the inception is actually a little bit different. So our founder, Artur Bergman, was the engineering leader at Wikia. I don't know how much, if either of you know what Wikia does, but it's user-contributed wikis for content that would not end up on Wikipedia typically. I think they rebranded as Fandom recently. So and the goal of this company was to basically monetize on some of this content. If you're ever, I mean, just the type of content that is on Wikia is a lot of the movie shows, series.
The Marvel universe, for example.
Yeah, or like if you want to know about, or if you want to cheat on any like a Netflix show, you can go like get synopsis of every episode.
Okay, I know what I'm doing after this broadcast.
It's pretty fabulous. So I've used it many times.
So that was the founder. What was his name?
Artur Bergman.
And he founded Fastly coming from that because it solved a need at Wikia, and he was like, I could make a company out of that, and did.
Yeah, correct. Because what Wikia had issues was, the wiki engine that we're using would take a minimum of 200 to 300 milliseconds. I think those are the numbers to actually generate a page. Most of their content was static in nature. I mean, these are not like, these pages, these wiki pages are not, changing all the time. They're kind of event-based. There's a new season drops by, or like, there is some activity, and generating these pages is very expensive. For engagement purposes, you want it to be fast, so you want to distribute it all around the globe. And at the time, none of the CDN providers were able to kind of guarantee, hey, like you could cache this page and then invalidate it, or do some other way of distributing your content. I think they say it was impossible. So Artur at Wikia and his team built a small-scale CDN that was able to cache content for a long period of time and then invalidate it only when it changes. So
So incremental validation, not the entire cache, but maybe
correct.
Everything that fit within a specific cache key of some sort.
Correct.
Yeah, and this was what was really interesting about Varnish to the Drupal project, for example, because imagine that you had your content, but that could appear on a block or in a listing, and it was very hard to track in a dynamic site where all of the traces of that content might find their way. So if you built the cache keys with the kind of the chain of all of the places that content came from, this came from this content, that came from that content, this is that type of content, then you could build a cache invalidation request that would wipe out just the things that had probably changed because you changed this one thing over there, and you could trace all the roots, and Varnish was really great for that, and ergo Fastly was great for that. Yep,
exactly. And that's exactly what happened. They built the system, it was great, and then figure, well, we might be able to make it into more of an offering. Varnish as a service.
Yeah, how's that going for you, by the way?
Yeah, it's okay.
You had an IPO, right? Last year.
Yes, correct. So things are going very well. From that base, and because Artur was also, he was one of the chairs of the Velocity conference, very much into DevOps. Hey, how do we build this new CDN that is, developer-friendly, real-time, and so on? So, from the get-go, we started off with, real-time invalidation, real-time stats, so you can get real-time analytics. Make a change, you immediately get data. Real-time logging, let's ship all the logs to you in real time, because those can be useful in case there are issues. And also, very importantly, real-time configuration changes. And also, in addition, the ability to program the CDN, which was also the new thing at the time, using, as you said, varnish configuration language, which is a domain-specific language. It does have certain limitations, and then we'll talk about how we resolve those. But it was kind of truly what we would kind of deem today edge compute. You could do certain things on the edge in a limited fashion. So that's how the company started. And I think a lot of the things that we kind of started with has been adopted by the industry. The real-time invalidation, like we were the first ones. Now there's some other companies that have facilities like that, but it was really kind of looking ahead. Hey, what is the new what is the new app stack need? Like, what are some of the new features that will allow us to build new applications, faster applications, and so on?
Wow, thank you. And I mean, along the way, a lot of new functionality has come into that. For example, I don't know. I wonder. It's just a blank in my mind. When did streaming become a focus, for example?
I mean, as part of as any we definitely started with more of this event-based purging, but also we do have a very, very good engineering team, some of the best, and as the network was being built, like we had a lot of capacity that could be used, and we really kind of excel in promoting getting good connectivity that could be used for things like streaming and being able to deliver the best streaming experiences.
Okay. And when did let's get Teddi involved in the conversation here and move a little bit to the history of Fastly from a security point of view. I think it's interesting to watch the industry that you're in rebrand itself from being primarily a content delivery mechanism, the cache in the cloud, to actually being viewed as a security layer. And I even know a little bit about that because there are two very obvious things that an application usually wants or needs, three that I can think of right off the bat. One would be TLS termination. So we've thankfully in the last 5 to 6 years successfully moved to an almost completely encrypted HTTPS experience worldwide, internet-wide. You very rarely find HTTP only sites these days. I don't. So any site needs that certificate to be at the place where their DNS resolves, and you guys do that. So you've got global TLS termination. That actually becomes, it turns out, a complicated problem to solve, is getting those certificates into the right place, into the right servers in real time, or something acceptably fast so that people can have encrypted communications and update their certificates. And that's actually one of the interesting inflection points with Platform.sh and Fastly. So that's one. And then there's the concept of protecting the origin. So the idea is that you've got one application or many applications that are generating the original content, and that goes out to the network, which then gets cached and delivered from the network. But that means that if an attacker could find out where that origin is and find its host name or IP address, they could bring that down, and then the network can't protect you from that. So protecting the origin is another security feature. Okay, and then of course there's the third feature, which is actually scanning the traffic as a web application firewall to see what kind of requests are coming in that might be nefarious and attacking. So those are all the things that I know about. Teddi, you're the expert. How did it evolve, and what else is there?
Yeah, those are all super important things. Natively, the Fastly Edge provides that TLS support. Now that is obviously scaled and grown over time. Now we have Platform TLS, which is the current iteration that we're in, which helps scale, helps you guys manage all those hundreds or thousands of certificates across all of your deployments. It's awesome. It's very robust, and it's iterated over time. But we also have DDoS protection at layer 3-4, which is provided by the edge that we handle and ingest, again, natively as part of the delivery platform.
So DDoS,
those are pieces.
Distributed denial of service attacks. So lots
Correct.
and lots of bots trying to bring you down.
Yep. Lots and lots of bots, lots and lots of requests. And when we look at layer 3-4, that's just based on IP addresses and volumetric data, right? It's fairly simplistic, but it requires a very large network to ingest, and that we have that for customers, and we provide that for customers. Now, when you talk about origin protection and looking at the actual content or the intent of a request, that's where the acquisition of Signal Sciences really comes in. Now Fastly did have and has had a WAF for many years, but it was meant for very unique use cases, or for simple use cases, I should say. And given that the Fastly delivery network was built for developers to be very robust and provide kind of the next generation solution for CDN, the Signal Sciences platform was built and comes from the same place. So the Signal Sciences origin story is much like the Fastly origin story, which is that our three founders, which were I should say, they're still here. Nick Galbraith, Zane Lackey, and Andrew Peterson were all working at Etsy when Etsy and Netflix were really starting to pioneer the DevOps movement. Etsy was in a place where every single developer had a complete copy of the website on their laptop, and they were doing 50 to 100 code releases a day. And that kind of scale couldn't be protected with a mod security based WAF, right? That's virtually what all WAFs were. So our founders set out to build a different way to protect those type of attacks and enter Signal Sciences. And essentially, after they built this tool and proved that it could work at Etsy, they then left and started Signal Sciences as a company. And really, Signal Sciences is built to be for developers and also enable the business, right? Security has often been a house of no, where they're constantly putting roadblocks in place, and we create shadow IT. Shadow IT meaning end users trying to come up with different ways to solve problems because security puts barriers in their way. You know, the classic shadow IT story is people getting access to email on their phones through ActiveSync before anybody knew that was an actually thing where people could get access to, their Outlook from their iPhones. So that's kind of the first classic story of shadow IT, but there's so many different facets of that. And so the Signal Sciences platform was really built to provide actionable, meaningful protection at layer 7 for your OWASP top 10 type attacks out of the box with little to no tuning and very low false positive rates, which are all common headaches when we look at a WAF product. But then we've really expanded beyond that. So yes, we consider ourselves a next gen WAF at this point, and we are in the process of rebranding to be Fastly next gen WAF. But it's not just OWASP top 10 protection. We provide ATO protection, we provide API protection, we provide protection against bots, like you were talking about, layer 7 DDoS attacks, which layer 7 DDoS is a little different than just a flood of individual requests. It's usually a specific attack meant to exhaust the resources of that origin server you're talking about. So someone is trying to make a really big database call.
Me and the audience, all these layers that you're talking about.
All these layers.
I'm a big fan of layer cake, but I eat them all at once. So what are they?
So there's,
or at least the ones that
layers.
are relevant.
Yeah, they're the 7 layers of OSI, and it's the model of essentially the way that a data center or a solution is built. Layer 1 is the actual physical layer, so walls, doors, keycard entry, that kind of thing. Layer 2 is the data link layer. Layer 3 is the network layer, so that's when we're talking about switching and routing. Typically, layer 4 is the transport layer. Layer 5 is the session layer. Layer 6 is the presentation layer, and then layer 7 is the application layer. Application layer is where the Signal Sciences or Fastly Next Gen WAF sits, that's where we're actually looking at the contents of the HTTP request. So every time you're in a browser and you hit return or click a button and it starts spinning up in your URL window, that's an HTTP request. And that is what we're actually parsing, the complete data, metadata of that HTTP request to determine whether or not it's something that's good, it's something that's bad, something that's unusual. But we're parsing that complete layer. So that's the deepest layer when we talk about a complete application stack or data center.
And when you do that parsing, is it like a huge list of regexps? Am I looking for, like, if attacker is using the words WordPress configuration directory and .. // then deny? Or is it smarter than that? It sounds like it's smarter than that. And is it how much is like per application and like only information that might be for my application versus how much is like predicated on the type of application? Like if I'm running a WordPress versus how much of it is you're looking at a global network and seeing all the behavior and modifying your response in real time?
Yeah, so all great questions. Signal Science's platform is not based on mod security, which is a huge list of regular expressions and pattern matching. And that was a huge problem with mod security and why our founders built Signal Sciences, because it was too simplistic to keep up with modern application environments, but also it was way too performance heavy. And so a huge list of regexes is going to greatly slow down an application environment. And we all know that what we're trying to do is get more content faster into end users' hands, right? So our founders actually built a proprietary technique that today we call Smart Parse, which under the hood is really just an incredibly powerful lexical analysis tool that looks at the complete context of the request to determine whether or not it could be executable script for the code language that it's written in. So it's like, it's super powerful. Does that make sense, Robert? Sorry, I know that was a lot of words, but I want to make sure that makes sense to our listeners.
You had me at super powerful.
Okay, cool. And it's really fast. Like, it's really fast. And not only is it super fast, so I'm just going to keep saying super. It's a super product. That's what I'm going to say. But we also give visibility to our end users, which is a big shift when it comes to the security world. Security is often a black box. There's things happening. We don't really know what's happening. We don't get the visibility. Much like the Fastly origin story, wanting to provide those real-time logs, we wanted to provide deep level of metadata and visibility to our customers so that they can understand what's happening, why it's happening, what we're doing, and the performance impact we're having. So customers can see live through our console exactly how much latency we're adding to the traffic flow by introducing this layer into the application stack.
And the acquisition was last year. How much of Signal Science core technology and product roadmap is now available for Fastly versus how much is still being brought in?
Yeah, great question. So it's all available to all Fastly customers, but that doesn't mean that it's all available at the edge yet. So we had our latest press release on being able to use Signal Sciences at the edge came out at the end of July. We're in early beta phases of testing right now. So work is ongoing to enable the Signal Sciences solution to be deployed at the Fastly edge, but we already have dozens of customers. We had a handful of joint customers prior to the acquisition who were all very excited about the pairing of our two solutions. But one of the core pieces of the Signal Sciences story is to be agnostic to the rest of the application stack. So Signal Sciences has a plethora of deployment options. So it doesn't matter what cloud you choose, what application language you're written in, what web server you choose, what hosting provider you choose, what operating system you choose, or even what CDN you choose to deliver. And those deployment options are going to remain because we understand that having security as a single layer is almost the most critical point for intelligence sharing or threat feeds, essentially across your entire footprint, but also for consistency in risk mitigation.
So you want Cloudflare and CloudFront and Akamai customers to also use the security layer so that you can mutualize and aggregate certain type of threat data?
Correct. Yeah, because we understand that especially because we're so big in the media space, a lot of media customers go multi-CDN, and we want to enable that, but still be their security vendor of choice because we're going to make things simpler for them, but also provide better risk mitigation.
Well, that makes sense. Cool. And what can we look forward to? Is there anything you can tell us about the general direction of where the industry is going, or where the signal science part of the team is going?
Yeah, so I think, nothing formal from a roadmap perspective am I allowed to share, but what I will tell you is that what I am seeing in the industry is a shift away from looking at these basic OWASP top 10 attacks. Right now, that's table stakes. If you have protection in place, it needs to be able to handle that. The shift is going into these abuse and misuse situations when we look at bots, like you were mentioning. I actually did a CPE credit training with one of our partners last week, and I talked about shoe bots, and I talked about promo code abuse, and I talked about price scraping, and all of these kind of abuse patterns that aren't necessarily directly malicious, but we want to be able to not only protect the customer's IP or intellectual property, we want to be able to protect the customer's resources and their spend, right? We've had situations where we've blocked very large scale attacks at an ingress point and been able to save customers hundreds or thousands of dollars on their AWS bill because they're not auto scaling to handle these large scale attacks. So we're not just looking at your basic cross-site scripting or SQL injection anymore. We're looking at protecting application resources, uptime, availability for customers by doing traffic shaping at layer 7, right? Traffic shaping is something we talk about at the network layer a lot, but it's not something that's typically talked about as much at layer 7, which is really interesting to me because at layer 7, we know more about what the person's actually trying to do than we do at layer 3, right? Because we know what they're trying to instrument, where they're trying to go. And some other things that we're looking at too is defense in depth is always super important. And I think there's some unusual pairings here. So
what does that mean?
Defense in depth, chaining together different sort of security solutions at different layers in order to provide a very good security posture.
Like having a bodyguard and a watchdog.
Exactly, having a bodyguard and a watchdog. So we actually released also in beta, but it's been we have a press release about an integration we have with Okta and their SIAM solution, which is customer access identity management. Essentially, Okta is moving into this space where they want to manage identity for any sort of platform who has customers that log in. And we have an integration with their risk API that allows them to make strategic decisions about enforcing additional authentication steps based on risk signals that we're sending them. So, as all of these, pretty much every company in the world, because of COVID, is going more online, has more, they want to adopt more users, they want less friction for those users, but also they need to provide a good layer, a good amount of security in order to protect their brand. We can now use additional behavioral patterns in order to help them direct authentication flows, which I think is really powerful.
I have a question about that because one of your competitors, won't mention, but they do start with cloud. They are responsible for basically filling up the internet with the most absurd series of CAPTCHAs that you could ever. I mean, I can't think of a site these days that I don't go to where if I have any security tool turned on whatsoever, then I'm instantly flagged as a risk. Whereas I'm just trying to protect myself, and instantly a CAPTCHA comes up, and a lot of them are unsolvable. Like I think one time I solved the CAPTCHA like 50 times in a row, and I swear I got every bicycle and lamp post in every picture that they showed me, and they still wouldn't let me visit the site. And it was like a really benign site. It was like not even like nefarious or something I shouldn't be looking at. I just happened to be on some sort of VPN or something, and I tested it. I turned the VPN off, and all of a sudden I'm trustworthy. Turn the VPN on and panic. Back to signposts and bicycles. So I mean, it's not going to be like that, is it? Please say no.
So the enforcement that the customer decides to use is up to them. Today, what Okta supports is enforcing MFA, not a CAPTCHA. And personally, I'm not a fan of CAPTCHA. Bots have proven they can pass CAPTCHA better than humans can. And Robert, I'm with you. I fail CAPTCHA all the time. I don't know why. I don't know if I'm just not paying attention or if I'm, I don't know. But I do it all the time. So, but no, we're looking more at things like asking for MFA or additional information or validating, like, this is your account photo. Essentially just trying to make things more frictionless. We actually just did a webinar with Okta 2 days ago, and I did a demo during that webinar, and we essentially showed the process where I log in to an app and it just allows me to log in with username and password. Then I attack the website from that IP address. And then after I attack the website from that IP address, then next time I tried to log in, I was prompted to use two-factor authentication with, in this case, Okta's Verify app. So now, granted, that was, a simplistic demo because I was sitting at my home doing the whole thing. But you get the idea where instead of just blanketly applying a CAPTCHA or multi-factor authentication, instead, we can do this in an intelligent fashion based on risk information that Okta is gathering across an entire customer's profile. So I think it's really exciting when we start to chain these kind of things together, especially when it comes to authentication or fraud use cases for checkout workflows and things like that.
I just love that we're in a conversation where your example happened to have the sentence, and then I attacked the website. Just casually, of course, like I logged in, I uploaded my profile photo, I attacked the website.
We do it all the time. Okay?
We do it all the time, yeah.
And I'm the one stuck filling out CAPTCHAs. I don't understand.
Well, we know how to attack them, but we also know how to clear the cache to get our IP address out of the list,
Oh my gosh, I never mind blown. I'm just obviously sitting
Instant
on the wrong
purge.
set of
Come on.
private keys. All right, nice. Thank you. That was a really great insight into like how far you guys have come along with the security stack and where it's going. Are there other parts of the security story that outside of the signal science part there that are also developing likewise within the company?
I mean, there's always lots of things. I don't know. It's
Okay.
lawyers and all that. We can't.
Yeah, I think what's
I'm just
unique
fishing.
is- you're totally fishing, and I'm not gonna let you catch anything. But at the same time, I will say, like, when you look at vendors in this space, they're doing a lot of acquisition in order to expand their functionality to provide, bot or RASP or API protection. The difference is that we can provide all of that through one platform. So we can fall into all these different categories. Like I've been through RASP RFPs. I've been through WAF RFPs.
What's RASP, please?
RASP, thank you for pausing me. Runtime application self-protection, which was an iteration of the code scanning world, where they thought, well, since WAFs aren't very good, maybe we can take our really awesome code scanning product and then do it in real time. The problem is it's very performance intensive. And because it has to be tied into the code level, you have to rewrite the logic over and over in different code languages, which creates inconsistency in security posture and profiles. So, but it's something that people look for, and as you can imagine, working with large companies, there's political conversations that happen. And sometimes we can get in on a RASP deal, but we can't get in on a WAF deal because it's a different person that manages the RASP than the WAF. So it's, but to us, it's all just nomenclature. It's all the same platform. So what we're looking to do is just expand and provide more protections, like I said, at layer 7. That's why I say layer 7, because it's not just WAF. When we look at WAF, that kind of pigeonholes into one, I shouldn't say it pigeonholes us, but customers focus on one kind of core set of features and functionality, and we do so much more than that with the individual platform.
Just like the term CDN would do the same.
Correct.
I tried to use the term to orient people, but to caveat that Fastly is not just an HTTP cache in the cloud. So you are much more. And back to you, Vladimir. I would like to ask you some questions about the edge computing story. Mm-hmm. So the industry's also, you and your competitors have all shown a lot of interest in not only storing static thingies at the edge, but actually doing dynamic thingies at the edge. And and at the same time, Amazon has come and made popular this concept of serverless, like a piece of code that you can just run, and you don't worry about the infrastructure, and you don't. It just input, output, and it's always there. It's always ready. It comes up fast in some cases, and that becomes an important issue. How fast does it come up? So you've got a story. You've got a product called Compute at Edge. Is that right?
Yep. That's
What's that product? Tell us about it.
Okay, so just we mentioned it before, so we started off with this, Varnish. Varnish is a service, being able to program the edge by using Varnish configuration language, but Varnish or VCL is limited in that it cannot do everything that we wanted. So this was the product that came out of it is Compute at Edge, and it is a compute on our servers using a WebAssembly technology. And for those that don't know what WebAssembly is, it's a binary format that is where you take your code, you compile it to WebAssembly, and it's kind of platform independent, and you can run it anywhere. It does have a number of useful features, such as you can sandbox it. It's memory safe, so that gives you some security benefits, code benefits. As far as if your sandbox crashes, it doesn't crash your whole machine, and so on.
It's also very performant, which is why it's included in browser-based applications to do more complicated, computationally intensive things like gaming engines.
Correct. Exactly. So we start off with WebAssembly because it is a intermediate format, and then we wanted to do to enable customers to have more of an expression of what they wanted to do on the edge beyond just header manipulation, cookie manipulation, some geolocation, conditionals, and so on, but have a full suite of product, access to the response body, rewrite content, do different kinds of decisioning, maybe like parallel invocation of or parallel requests to multiple origins at the same time, and so on. So
can these WebAssembly containers network? Can I make an API call?
Yes. So currently you can it's available. The Compute at Edge is available, and it's just you have a domain. A request comes in, and you for the request that you initiated, you get a Compute or WebAssembly sandbox. And within that WebAssembly sandbox, you can do some code, and you can access some backends. So you could go somewhere else. You don't have to necessarily use you don't have to go anywhere. You could all be edge-based. You could just do, pull up, and we expose some geolocation, for instance, variables, networking variables. So you could technically do everything on the edge without even ever interacting with the origin.
Okay, so it's powerful enough that if I wanted to make my own search engine, I could write it completely in Fastly Wasm, and every time I got a search term, my container would go Google it and then package the results and give those back, right?
Exactly. Yeah.
Okay.
Yep.
And if I have a database someplace and a way to access that, I could do that as well.
Correct.
So it's really like a web server at the edge.
Yes.
Is there a concept of storage?
So currently we do not have a concept of storage. So we will rely on other storage engines. So we had a number of customers that have made creative uses of object storage from likes of AWS S3, Google Cloud Storage, where they use them as a key value store. It's actually very, very, very good. Where they can either use them as just simple file storage, or it could actually even have things like, hey, configuration file. This is my JSON file with some configuration that my computed edge parses out and does some action.
Okay. So you gave me some theoretical examples. What are some of the real world use cases that you've seen, or any implementations that have been particularly impressive to you?
So a number of different, so we kind of put them under a category of for instance, pre-flight requests. So pre-flight request is a request comes in, you need to check it against a certain criteria. So it could be a security. You can say bot. Hey, is this a bot? Or you could do some other checking. Hey, this is a newspaper article. Like, is this user allowed to have access to this specific article? And then based on the response from the authentication backend, if you will, you provide a cached version of the page. So those are some of the actual use cases that we had. We've also had a number of cases where there is the database layer might receive different inputs and these inputs might not be sorted in a proper way or might have some extraneous data, and we will actually normalize the queries or normalize the inputs so that we can have actually better usage of our cache.
Can the processes be long running? So I can imagine if I've got a nice compute environment, and let's just say I want to calculate a huge prime number or something, it was going to take a day. Can I use it for something like that? How is it metered? Would that be practical? Would that be stupid?
That would not be practical. So currently, it's CPU usage, also some network usage. There's a formula. So currently the total runtime, and I might be wrong at this point, they might have bumped it up, is 30 seconds. So you would not be able to do prime numbers, and really this is intended for things that should be pretty quick. Pretty quick. 30 seconds may not be too quick, but at least it shouldn't be.
It's 2001 hours. Calling, by the way. 30 seconds is really quick.
Exactly. So it would be mostly doing things that make sense. Hey, like decisioning on the edge.
Okay. That makes a lot of sense. I'm curious from the developer experience point of view, what's it like deploying these and testing these?
It is actually quite fabulous because we have a pretty good environment where, and actually we have tools where you can actually test it online and kind of push it. But typically you would write your code, compile it, and then kind of use our API, or we have some CLIs that will allow you to actually upload it to our service. And then, very quickly, within seconds, it would be available to you. So it's.
How do I test though? What's a typical setup? Because testing is hard. So like, I've got to know what types of requests I anticipate, but then when I put it out and start observing how it's being how it's behaving in the wild, then I'm going to get requests that I didn't anticipate, in situations I didn't anticipate, and like I've got to look at logs. Where are the logs? Where do I get my logs? And is there like a test net versus a main net concept? I mean, what do I do?
Okay, so we do provide a local testing environment, so you can actually, whatever code you write, there's the Fastly CLI command that allows you to upload it, manage the versions of your software, that allows you to say, hey, like serve this, almost kind of like the PHP serve, and then you have a local environment you can test. We provide and as part of this CLI, there's a log that you can actually use for both your local environment or remote environment. So real-time log tailing, and same as with our CDN or Varnish environment, you can stream logs of your computed edge app to a logging endpoint of your choice. But there's definitely, as I said, you could just say, hey, Fastly log logs, and then like it will basically it will tail your logs in real time.
So what's the difference between an environment like that and Lambda on AWS, conceptually and practically? I mean, why we're talking about fast to start up computing environments where I can run arbitrary code, do a lot of things, have some limitations, and it's all, pay for what I actually use based on requests and CPU. I mean, it sounds really similar to serverless. Do you guys market it as serverless?
I think there may be some wording there that it is, serverless, and it is very much like this. The difference, I'd say, the main difference for us is just the cold start. Cold start meaning like how long does it take for the environment to come up? Because again, these shouldn't be long running processes. So our benchmarking is concluded that it takes about 35 microseconds to actually launch one of our sandbox containers versus like milliseconds for some of our competitors.
So it's better than serverless. There's your marketing pitch.
Correct. It's better than serverless.
Super serverless.
And I think the main kind of advantage to this is that these are like cheap to create, cheap to destroy containers or sandboxes, which gives you a lot of security benefits, because you don't have to like keep containers or around for the next request, because it's very expensive for you to kind of keep starting them up.
So are you saying that you can start the container and serve the request in 35 microseconds?
35 microseconds for the sandbox to start up. So you don't have to, because some of our competitors are using basically where they'll keep the containers running to just reduce the time for the container to start up.
Which is fine, but that probably makes it expensive.
It makes it expensive, but also there's a security, because you might have like things left over from previous sessions, or it just opens you up to potential security issues. Versus in our implementation, like you create it, the request is over, you destroy it. So it's there's not like leftover data that might be from a previous session because of a coding issue or something else that could be exploited.
So how are you shaping developers' minds throughout the application universe to take advantage of that? Because what's interesting about that is that WASM is a standard, right? But there's never going to be another CDN security edge computing company like Fastly who has exactly the same product. So to adopt this, I have to really learn how to use your product. How do you shape the developers' thinking such that it's just naturally leading them to you? Are you investing in like general WebAssembly know-how? Are you making architectural principles like the 12-factor app or Jamstack, where you do that to like describe what your product does best, so that people will think like your product works best? We're not really saying, hey, you have to code for WebAssembly, because you don't code for WebAssembly. You code in a language of your choice. So Rust being one, and now we support WebAssembly and JavaScript, and then you use that. You compile that code into WebAssembly using our tooling, and then it will just run. So it's not that we're necessarily saying, hey, like if you learn this WebAssembly thing, it's unusable elsewhere. You can still use your code elsewhere as well. It's not but you wouldn't. I mean, this architecture demands thinking about your application in a very specific way that you can't necessarily run elsewhere. Nobody else is giving you 35 microsecond WebAssembly startup time distributed around the world. Or am I missing something?
No. So that is correct. So in this case, yeah, I mean, it does allow you to build very fast edge applications and avoid some of the pitfalls of having the containers that are long running.
So usually, if there's a technology that is unique, it enables application-specific use cases to be realized. Have you found anything like that? Like, is this the technology that enables real-time peer-to-peer local gaming with full virtual reality experience or something like that? Because there's no latency, because you've got like the WebAssembly thing, like down the block in the POP that you have in your data center in your city. What are the like the emergent applications that nobody's ever heard of?
So the emergent, I mean, to be honest, I mean, we're still scratching the surface of this, and I think it's not even us that will come up with the next killer application. It's going to be one of our customers, but at least we're providing the same with like the history of AWS or other clouds. Like they provided the kind of underpinning, and then the customers came in and made awesome things on top of it. So I think we're here to just enable customers to build solutions. I mean, although we do have we have this very interesting implementation of Doom on the edge, where we're actually rendering images on the edge, and it's super interactive, and it's just the show. It just shows the power of our platform. So
I like how the game Doom, and Teddy, I see that you're about to jump in, but I like how the game Doom has become kind of the hello world of containers in general. Like, not only can you run it, but like, can you kill it and run it again really fast? And just the phrase "Doom on the edge" is so ominous, right? Like,
more than attacks at layer 7, I think so.
I mean, this show is making me nervous. Attacks on layer 7, on edge, Doom. Teddy, what were you going to say?
I was just going to say, kind of pointing out a couple, at least interesting use cases that I've heard with Compute@Edge in our customer base. And Vlad kind of talked about this earlier, but not quite so directly, which is the paywall situation, right? We have some clients that are using Compute@Edge to become the paywall. If your listeners aren't familiar with what a paywall is, it's essentially the ability to gate access to different content based on the level of subscription service that a user has, right? So I think that's been really interesting to see customers use that. I think as far as like the marketing effort goes, which I think is what you were asking about, Robert, we also are doing a lot of internal programs to get our field tech teams like to think about unique ways to use this and build kind of proof of concepts that we can then show customers. Because as you know, the field is talking to customers every single day. And sometimes what we need is to recommend things to customers about what they could do with this. And we have a group of awesome sales engineers who have expertise in this. And so we go through, actually, we're going through another phase right now where there's kind of a competition into designing different things that could be done on Compute@Edge internally to like help us kind of drive business, write more blogs about the opportunity that customers have with Compute@Edge.
Great, thank you. And one more interesting to me technical question is, how does that chain with the actual cache layer? Is it before, after, or both? Can I decide? And how can the Compute@Edge environments interact directly with the cache layer? And how or why would they do that? I never ask just one question, by the way.
Oh yeah, no worries. So there is a number of different implementations. So we call it a chaining. So you can actually use Compute@Edge in front of a varnish service. For instance, you can have a varnish service and then Compute@Edge, or vice versa, depending on your use case. There are some for the Compute@Edge. We do have a caching layer. It is currently using varnish as its caching layer, but that's something that is being kind of.
I'm not surprised.
I know it's crazy, but but that's something it's being worked on. So we expect to have a more. We're going to be expanding on that so that there's a significantly better caching and so on.
Can I do things like put the WASM container before the cache, and the WASM container can check the Fastly cache to see if it's stored locally and make a decision based on that?
Yep.
Okay.
Yeah, exactly. That's the kind of the paywalling example. Like for paywalls, you don't want to be checking like every time. You only want to check like that the customer actually is allowed to see this article. If the customer is allowed to see this article, you actually check the cache and pull the content out of the cache.
Okay. Yeah. All right. That makes sense. What else? We've got a couple minutes. This is your time to brag. You work at a great company. Either tell us about your product, something that we haven't talked about, or just tell us like what the culture of working there is like.
Okay. I mean, so as far as the computer edge, we mentioned some of these, the pre-flights, but there's also we're going to have customers are testing some of the geo using the geolocation libraries on our edge to actually make decisions around routing. So for instance, if you have multiple data centers, you can actually directly from our edge make decisions, which data center to go to. We also have a number of experiments around. I lost my train of thought. Anyways, I don't know. Sorry, but actually, sorry. So one other useful, and this was an announcement of a product called Nearline Cache, where we actually built another product on top of our computed edge, which is the ability to store intermediate objects that we might expire from our cache in an object storage of our choice. And then use kind of free egress to actually make that numbers work well. And this was done just using our platform to actually save our customers money and improve performance.
I'm not sure I completely followed that, but would that be akin to like a glorified edge side include, where all of the includes that you generate you're storing so that you can include them faster?
You could say that, but so I mean, we could do that today, just caching them. But you might have, you might be on a cloud provider that has a pretty high egress charges, and if you have a very large library that might expire, you could actually take that content and in real time using our computed edge actually store it on an alternative. Object storage that is cheap, that has cheaper egress to increase performance and lower the price, if that makes sense.
Okay, that makes sense. I'm all about lowering my egress price.
Yeah, and then you mentioned kind of earlier, like when we start doing streaming, actually that has also been a pretty big area that we've seen interest in. Doing things like from customers. Hey, how do I manipulate my manifests? Like if you're familiar with HLS manifests or other manifests, or on how the video is playing, how do I modify them without having to like go all the way to my packager back on the origin? Like I want to take my existing manifests, manipulate it in some ways, like put ads in, like, or do something along those lines. So that has been something that we've seen quite a bit of interest and customers playing with it.
Awesome, thank you. So we are at pretty close to the top of the hour, which means that fun time is over. We are going to have to wait another week to bring up another great topic on Deploy Friday. Thank you both, Teddi Poehls, Vladimir Vuksan, for joining me from Fastly, a proud partner company of Platform.sh, part of our product. We've depended on you guys to do a great job from day one of our product, and it's always been wonderful working with you. So thank you for joining me, and thank you for listening to you out there. Come back next week for another episode of Deploy Friday. Bye-bye.
Bye.